Let's start from the first question. The first question says the diagram shows part of human respiratory system. The structure labeled X and Y change the volume of lungs during breathing. So we have to name the structures. If we look carefully, the structure X, what do we call this structure X? This is rib cage, right? Touch your rib cage, touch it and feel the rib cage. This is the bone which protects our lungs. Now, what is Y? Y is pronounced as diaphragm, and the spelling for it is DIAPHRAGM. Now, what is this diaphragm? Just imagine diaphragm as a motor which helps our respiratory system to pump air in and pump air out. How does it do it? It does it by increasing and decreasing the volume of the lungs. All right, creating space for the lungs by moving up and down. Once it contracts, it moves down. Once it relaxes, it again moves up. Okay, describe how structure X and Y move to increase the volume of lungs. Let's talk about rib cage. Keep your hands on your chest. Rib cage moves up and moves out. So X, that is rib cage, moves up and out. All right. Now Y, that is diaphragm. What is the function of diaphragm? As it contracts, it moves down. When once it is down, it is like this. So more space is there. More space means more volume. That's when the air rushes in. All right. And when it relaxes, it moves up again. Or we can say flattens. Let us move on to the next question. Mike and Rajiv plan an investigation to find out how running speed affects breathing rate. Name the equipment they must use to measure their breathing rate. Alright, how can you measure something? If they want to measure their breathing rate, they can use a stopwatch, either a stopwatch or they can use a timer, right? Now, state one variable they need to change. Now, let us come back to the question now. Underline this with me. How running speed affects breathing rate. So what are they changing? They are changing their running speed, right? Yes or no? And they're investigating the rate. What we change during an investigation is known as independent variable. So what are we changing right here? We are changing speed. So write down speed. State one variable they need to keep the same, that is the control variable. We have to have control on this, right? Then only we will get the right results. Now, if we look carefully, what should they keep same? They can keep same the duration, or they can keep same the person doing the running. If they are using different person, they will get different results, right? Person doing the running. Imagine you doing a running. You will have different rate and your brother or your friend will have different rate. So we have to keep the same person doing the running. Then only we can investigate. Yes or no? So this is our control variable, which we keep same during the investigation. Suggest one way they record and present their result. How can you present a result? How can you record a result? What do we use? We use either graph, or we can use a table. All right. Let us move on to the next question. I could draw a diagram of an atom of lithium. Lithium, you can imagine it as an atom or an element. All right. It is one of the element. Okay. The electrons in the charge cloud are held in position. They do not escape from the atom. Escape. Explain why electrons in the charge cloud cannot escape from the atom. Use idea about charges. See how to frame the answer. We have to use idea about charges on a particles in an atom. So let's talk about an atom. This is the nucleus of an atom. Inside the nucleus, two persons are resting. First one are the protons, and the second one are the neutrons. Protons have positive charge, right? Neutrons have no charge. Now, surrounding them are the electrons. These are the electrons. And what charge is on electrons? Yes, you said it right. It is negatively charged. Now, what is holding the electrons together? Why are they not escaping? To know this, you should know one basic thing, that is that like charges, for example, positive charge and positive charge repel each other, and negative and negative also repel each other, right? Two negative people repel each other. Yes or no? But positive and negative attract each other. Unlike charges attract each other. So if this proton is attracting this electron and this electron is also attracting this proton, the proton and electron, the force between them, that is electrostatic force of attraction, will hold the electrons, will never let them escape. All right. So what we will write down in the answer? Write with me: positive charge on protons. This is the main reason why electrons are not escaping, right? We can write down n negative charge attract each other. Let us move on to the next question now. Aiko wants to draw a diagram of an atom of sodium. Describe two ways an atom of sodium is different from an atom of lithium. Now, you've never heard about the word lithium, but you have heard about the word helium, right? So, if this is helium atom, let us compare this helium atom. We were having two protons in helium atom, and we were having two electrons as well outside. Now, look very carefully. Helium, let me write down helium also over here. This is a helium atom. All right. Now I want you to observe this helium atom. All right, wait. And this lithium atom. What changes can you see? If we look carefully, here are two protons, and over here are three protons. Yes or no? Can you see? This in the same way, electrons will also be different. So in different element, what I'm trying to say is focus over here. So in different elements, there are different number of protons and different number of electrons. So if we are talking about sodium, how is it different from lithium? So you can write down that different number of electrons. Sodium will have different number of electrons and different number of protons. Or we can write down different size as well. Both of their size will be different. Yes or no? Imagine a bag of two balls. Then imagine a bag of four balls. As we are changing the number of balls, the size is also becoming different, right? In the same way, as the electrons and protons are increasing or decreasing, the size varies. Let us move on to the next question now, learners. Carlos investigates what happens when light hits a mirror. When light hits a glass block, complete the diagram to show what happened to a light ray that hits the surface of the mirror. What can you observe from this is that we have a light ray. This ray of light is the incident one. So I can write down this is the incident ray. This line right here, that is 90 degree, is known as normal. Basically, first we have to measure this angle. This angle is angle of incidence. Measure it using a D or protector. Don't forget that we always measure from the normal. One common mistake which learners do is they measure this angle from here. We measure this angle from the surface. Never measure from the surface. Repeat after me. We never measure from the surface. What is the sole reason for that? Why are we measuring only from the normal? Because the surface can be uneven as well, which will give us different value. So we always measure from a 90-degree line, that is the normal. Very good. Now, how can what do we have to do in this question? We have to draw the reflected ray. Why have we measured this angle then? Why have we measured this? Why was it so important? Because we know that angle of incidence equals to angle of reflection. All right. Always remember angle of incidence equals to angle of reflection. This is the main law of reflection, right? So let's say this angle is 40 degree or 45 degree. So what I will do is first I will measure 45 degree from here. Then I will draw the line. Don't forget to mention the arrows and use your ruler and pencil to draw these diagrams. Always measure the angle. This angle 1 should be equals to this angle 2. This is what a reflection says, right? Angle of incidence equals to angle of reflection. And what is the name of this line? The red one. This is known as reflected ray. Very good, learners. Now let us jump from reflection to refraction. This is a light ray. All right, this is the incident ray. Now it is entering from air to glass, from a less dense medium to a more dense medium. Imagine a ball in your hand. If you will throw this ball in air, it will have a different speed. But if this ball enters water, if this ball enters water, will the speed of ball change or not? Think about it. Yes, the speed will change. Due to this speed change, the direction will also change. Imagine light ray as a ball. When it is moving in this direction, as soon as it is entering water or glass that is more denser, it will slow down. And due to that, it will bend towards this 90-degree line, which is known as normal. So if it will bend towards the normal, I will draw a line like this. This is angle of incidence. Now this is angle of refraction. Don't forget to mention the arrows. Arrows indicates the direction of the light ray. Now at this point, I will draw a normal again. At the point at which it is meeting, I will draw a 90-degree line and this is the normal. Now think about it. I'm changing the color for you. Think about it. It is going from a dense medium to a less dense medium. Are you with me? So opposite, the speed will increase. Repeat after me. The speed will increase. So it will go away from the normal. Very good, learners. You did absolutely good till here. Let us move on to the next question now. All right. When light goes through a prism, the light is refracted and split. Underline this word split. What is the name of this process? When light is splitting, what do we call it? We call it dispersion. All right, learners, that's it for today's video. See you in the next one.